you'll see a little, as long as it works.
Does this mean we can't get distracted?
Well, some days I might film this class, sometimes I might do the other class, as long as I get, if we're covering stuff. If we're just taking a quiz or something or having a work day, I'm not going to film class. But anyway, this so if you're absent, you can just watch these videos or you can scroll through them and get the notes, whatever. I mean, it's up to you. Some people have said they like watching them at double speed.
Oh, I did that with chemistry because the videos were 18 hours long.
Well, they'll be.
So now they're only 6 hours. Wait, no, that's wrong. 9 hours.
But I mean, if the school ends up getting closed and then we go like online, my class will basically be every week you'll have like one video and it'll be about an hour long.
That'd be awesome.
So, well, some people were like, oh, an hour video. I'm like, yeah, an hour video for a full week.
It's better than
So
30-minute one every day.
you can watch 10 minutes and stop it and then come back later.
If we
So
get shut down, don't we just get shut down for like a week or two and then come back?
maybe, I don't know. I'm just saying, last spring, that's how I ran my classes last spring. Was I just would post one video with all the content, pretty dense video. It would cover everything.
Like and subscribe.
And then, please like and subscribe, poggers, all that stuff. You have
I
to.
don't know what that is.
I don't either.
Something from Twitch. It's like a guy making an excited face, I guess.
There's
Okay.
a man that live streamed him like shooting himself.
Oh my God, Nay, stop. Okay. The first couple of problems here. Let's go over some stuff here. Okay. Tomorrow we'll have a work day. Let's set this up. So curve sketching. So if you just kind of briefly flip through this problem set, you'll notice that
It was sickening.
there's 16 problems on the front page, the front 2 pages they're all polynomials. Okay, no fractions involved. And then 17 through 36 are all what we call rational functions. They call them like a rational number is like this. 17/9. That's a rational number. It's going to be expressed as a fraction. So a rational function is a function that's kind of analogous to this. It's going to be like a polynomial. Yeah, it's going to be a polynomial over a polynomial. Well, there's some, it's a little bit of a misleading. Like for example, is this a rational number? Pi over 4?
No.
That is not rational because pi is not a rational number. It's transcendental. So anyway, for rational number, it has to be 2 integers. For a rational function, it's got to be 2 basically 2 polynomials. Yeah. So you can't go e to the x over x squared plus 1. That would not be rational. We don't need to get into the weeds of like what's rational, what's not rational. It's not that critical. What is critical is understanding. So here's the bird's eye view of this is what we're going to try to understand in this whole unit here is what features of functions create things like on a graph, things like x-intercepts, y-intercepts, asymptotes, things like that. Does that make sense? So let's just do the polynomials first. How do you graph? So most of these are going to be very quick.
Are you doing number 1?
Yep. How do you graph something like this? Well, first of all, let's back up. What shape is that?
It's a
Parabola. Right. So
parabola.
this raises the question of, okay, is it a parabola or is it a line? Because that's the equation of a
You
line.
always go for the biggest exponent.
Very good. Yeah. So this is what I would call a dominant term. So this term dominates the behavior. What?
Oh, never mind. I got you.
So this term is the dominant term. So this is going to be a parabola. And then, so to figure out what a parabola looks like, well, what if I just factored this? Factor out an x. Do you see now what 2 pieces of information we could get out of this now? Very easily?
Yeah. No,
I remember
There you
doing
go.
this last year.
I don't. Wait, so then wouldn't that? Oh.
See, I was wondering, when does this function hit 0? What
I
x
just
values?
plug in 0.
Well, actually, that's true. But generally, if I want to know when does this function hit the x-axis, I would ask the question, when does the y 0? Make sense?
Mhm.
I'm basically asking this question. When does y be 0?
And does it?
Now, when I factor it, I can obviously see that if x was 0, I'd have 0 times a thing, which is 0. So when x is 0, and what's the other x value that makes it 0?
-5.
-5, very good. So my graph reflects that.
Oh, I got
So it's
you.
now, did you see how once I had those x-intercepts, the parabola is pretty much, he's got to be where he is.
Wait, so you can do,
You gotta be,
but if -5 is x, you can put on the outside. Oh, Western 0.
So the zeros were happened when x equaled 0 and when x equaled -5. Everyone okay with that?
Okay.
So this, say sure, Maddie.
do you not like sure?
Triggers me.
My turn.
Sure.
Say sure.
That's my boyfriend's pet peeve too. You guys should be friends.
Well, the word has meaning. It's like, do you want to come help me move?
Sure.
Sure.
That's like, I don't want to, but I'm gonna say yes.
Sure means, yeah, sure has a.
When people are like, do you want to do something? You're like, we can. That's my pet peeve.
Another one is when someone goes, when someone wants to ask you for a favor and they say, do you want to? Yeah, that's, just say, could you please?
Yeah, don't say, do you want to do this? Because no, they don't.
Hey, could you please pick me up at the airport on Saturday? I'd really appreciate it. Oh, sure, I'll do that. Do you want to pick me up at the airport? No, I actually don't want to do that.
But I will.
I mean, I would, but yeah, anyway, so that's.
Can you drive me to the airport? Sure, I can.
So when you're asking for the zeros, you're only asking with y. How is y equal 0?
Yeah, we're asking for the, so saying the zeros is saying the x-intercepts.
Okay.
Let's do one or two more, then we're gonna move on.
Okay.
Next, you've got, this next function is y equals x squared minus 16. Now this one,
This one's just blah, blah.
You can take the square root.
yeah, this one you can solve a different way, but just for fun, let's factor it, because there's an idea here where the factorization tells you a lot about the structure of the function. So you can certainly set this equal to 0 and solve, like, I mean, add the 16 over and take square roots, right?
Yes, sir.
So we already know the answer is plus or minus 4. Does that make sense? But how else could we have found that? Well,
There was this rule last year that I forgot.
you can fact this is a difference of squares.
Yep.
This comes up a lot, by the way.
It's x minus 4 and x plus 4.
So I wrote it wrong. Sorry.
I remember this a little bit.
So this is a very famous and commonly used identity
Is it
where,
by gram?
huh?
Never mind.
Graham's number? No. This is just something that comes up in a lot of algebra.
I used to know little graham cracker.
Make sure you know and understand this one, guys. That is one of the more fundamental and just, like I said, commonly used in commonly used identities in math, which comes up all the time. Do you see how it's being used here? So it's x squared minus 4 squared can be rewritten as x plus 4 times x minus 4.
I got you.
Are there any questions on that?
Sure.
Also,
What?
also.
It's also a parabola. Now this is an interesting one because we could have thought of this. This is one of the fun parts of math, I think. This is the different ways you can think about something. So like this guy, I could have thought of this as a parabola shifted down 16, right? But now we're shifting our thinking and saying, well, I can think about this as a parabola whose intercepts are -4 and +4. And those are, of course, the same thing.
And that's a lot more accurate, isn't it? Like,
Yeah. I would think so.
well,
That first framework would have told us that this y-intercept is 16, right? -16, sorry. That makes sense.
Yeah.
So if you shift this parabola down 16, it's now going to cross the y-axis at -16. So that's one piece of information that
Okay.
emerges very quickly when you think about it in terms of shifty wifties. In the factoring way, you get the 4 and the -4. So
This is bringing back old times.
it's what?
Bringing back old times.
Algebra 1.
Yeah.
The good old days. The good old days.
I did absolutely nothing in algebra 1.
Paying off now.
Okay, anyway.
It's really good.
Let's do one more. Let's maybe do 2 more.
We should do the ones with the 3 parts.
Oh no. I guess let's do 8. That one's pretty scary, right?
Yes.
Yeah.
You just factor.
He's scared.
Just factor.
You just factor.
Just factor.
What's
Hey,
the
bros.
first thing we should do?
Factor.
Well, very good. Now, I'd actually like to factor out not just x.
Negative x.
Let's, because this lead term, things just are nicer if this lead term is positive a lot of times. So I'm gonna factor out a negative x. Let's be really careful with this next step. What's left over here?
X squared.
Positive x squared, very good. Now the next term,
Negative 6x
negative 6x, and the last term is,
plus 8.
okay, let's take a
Breather.
little breather here.
I can't breathe.
Are there any questions?
Yes. So from this point, how do you grab it?
We're not done yet.
Oh, okay.
I'm thinking of a more question, just a mechanical question. Anyone have questions on how we got from here to here?
FOA Métis?
Is that like a Drew Bledsoe jersey? What is that?
It's Julian Edelman.
Edelman. Okay. Wasn't sure of how retro. That's actually not retro at all. He's still active, isn't he?
Yeah, they still wear these.
It's nice.
Who's your-
Some question about how do you factor out the x?
Factor out
X cubed, how do you, or x to the,
this guy.
yeah, how do you get rid of the 3?
So we notice that every term here has an x in it. That tells us, okay, we can factor out an x. That's the first step. And once we have that negative x written there, we basically ask the question, what has to go here so that this times this makes the thing we had originally? So negative x times what makes x cubed? Does it make sense why negative x times x squared would make negative x cubed?
Yeah.
That's kind of how we're working it out. So in general, you'll see all of these, if you factor out a single x, you'll see all of these terms have their powers reduced by 1. So the 3 becomes a 2, the 2 becomes a 1, and the 1 becomes a 0. Cool beans?
Cool beanies.
That's an entity. Okay, now, May says, well, how do you graph it now? Well, can you factor this?
What? Oh, isn't this when you do like the what times what equals the middle and then what plus what equals the end? So it'd be like negative.
You got that.
Wait, so then it
What
would
two
be,
numbers add up to be negative 6,
oh.
but multiply to make it positive 8.
Oh, negative 2, negative 4.
Negative 2 and negative 4.
-4, -2.
Wait. Just pause.
Hold up.
For a brief
Wait a
second.
minute.
So you do numbers that add up to be the middle number, but multiply to be the end number.
Yep.
Okay.
I need to write this.
Maybe we should do a couple practice problems of that.
Yeah.
Ooh.
No, I remember. I remember.
Okay. No, we'll do 1 or 2 as an intermission.
Too
We'll
bad.
we'll just practice a couple just for notes purposes.
Still a little,
Are you?
the whole faculty.
Kira, what are you drawing back there? Are you imagining that you're Spider-Man?
No.
Is that your web?
Are you getting all of this on video?
Yeah.
Fantastic.
You're famous. It's going straight to TikTok.
Oh.
TikTok's shut down.
Yeah.
I
It's
would,
not shut down.
it should be.
It's a national treasure.
It's in there.
Okay, a couple practice ones, just for, because yeah, that's something you got to know how to do, or you're gonna be lost.
You're in for a long year, Mr. Cole.
Let's just do a couple random ones.
Algebra 1 slash.
That's when you can factor. Let's do 3.
No.
Oof. Okay.
Not you, my pencil.
Plus. Why does it have to?
Is
All right.
Oh, I think I got it.
Let's look at it here. So don't shout the answer out. We're just gonna do it together. You ready? Don't shout the answer out if you know it. So I want to give everyone a chance to think through them. But I don't want to spend too much time on this. TBQH. Okay, so then to factor this, we go, what 2 numbers? And by the way, is everyone clear on why this little technique only works if this number is 1?
Yeah.
If that number's not 1, you got to do some guess and check to factor it correctly. But a lot of times when you're doing So the college algebra, pre-calculus, calculus. A lot of times it's just something simple like this. What two numbers add up to 9, yet multiply to be 20? 4 and 5. So what are the solutions? If this is an equation set equal to 0, what are the two solutions then?
-4 and -5.
Very good. So we're graphing this, the parabola would cross at -4 and -5.
Do you not put the x squared in front of those
No,
parentheses?
that would only be if,
Oh wait, no, I get what you're saying, but how come? Never mind. I understand.
So suppose for a moment the original equation had been x to the 4th plus 9x squared plus 20, sorry, 9x cubed plus 20x squared.
That's when you factor it.
Then we could have factored out an x squared, and then we would have had an x squared outside the whole time, but that's different. We're gonna get to that soon.
Okay.
So don't worry about that. Okay, so next, how about this one? Let's see. Now this is where it gets tricky.
I don't
Yeah,
know.
so they gotta be, one's gotta be negative and one's gotta be positive. How do I know that?
Isn't it?
And the negative number has to be the bigger digit.
True, right. So it's gotta be, first I know that one's negative, one's positive. Because they multiply to be -28. And then I know that the negative number is the bigger of the two. It has a greater absolute value. 20%. Because their sum is negative. So it turns out,
So it'd be 7
-7.
and 4.
very good. Okay, so my x-intercepts would be at 7 and -4. Lastly, this is a 1 here implicitly. So you have x plus 7. So this guy's x-intercepts would be -7 and +6. All right, I hope that was a sufficient review for you.
It'll get the job done.
It'll get close enough for government work, as they say, right? As Michael J. Knudsen said. All right, how are we feeling about that?
Can we go
All right.
back to number 8?
Oh, sure.
Because I just
Certainly may.
put the negative x in there.
Okay, so what x value would make this entire thing equal to 0? Let's see. What would I have to make this x value if I want its entire product to be 0?
I don't know.
0. If I made x be 0, it'd be 0 times who cares times who
So then
cares.
it'd be like 2 and 4.
Yeah, so we got, this gives us x-intercepts of 0, 2, and 4. So 1, 2, 3, 4, 2. So this guy has 3 x-intercepts.
It's probably the squiggle.
Now what shape is that?
It's not from.
That's the bleep bleep.
So now he's negative though, he's a negative blue blue.
So it's.
So he has to have a shape kind of like this, right?
It's just.
Does that make sense to everyone?
So wait, can you draw it out though? So.
Well, okay. I have to pause for dramatic effect, obviously. So how does that fit on here with these 3 x-intercepts?
It goes.
It goes. It's flat.
No, no, how I feel about that.
I don't either.
That graph?
It's lit, bro. It's weird.
Hey, lit, bruh.
Okay, let's do one more.
What about
Look at
6?
7. 6, come on, you can do 6. A
No.
little bit of guess and check on 6. Because that number in front is a 3.
Yeah.
If you really want, we can do it together, I guess.
Thank
Let's do
you.
7 first. 7's more interesting.
Wouldn't that? Can't you just divide out x?
For 7, yeah. So here, while I'm laboriously erasing the board here, try to figure out 7. And I agree with Kayla. Factor out an x squared is your first step.
If you say so,
I do. I say so. Trust me.
even if I have to.
Nope. You don't have to do anything. We all know that.
That's true.
Don't have to
We
do
don't have to
anything.
come to school.
Nope. Don't have to do anything.
Wait, did you get this one? But then don't you have to factor that out? So it's just x.
I think you guys.
You have to factor out that though. I don't know.
All right.
I don't think you did it earlier, did you?
Okay, that's our equation, right? What did we get? I liked Kayla's idea here. They both contain an x squared, right?
Take it out.
Factor that out.
What is the difference?
Now, let's see. How do you feel about this one? So what do I have to put there, T Hall?
X squared,
Very good. And what else?
4x.
Just
Close.
negative, just -4.
Oh, yeah.
Just -4. Then we can check our answer really quick. Does this times this make that? Yep. Does this times this make that?
Yep.
Yep. Okay. Now,
Thumbs up.
can I go further?
It's the difference
Yeah.
of squares.
Let's difference of squares again.
X squared, X plus 4, or plus 2.
Okay.
So do you have to go even further and do X plus 2, X minus 2?
What?
Like split up X to the second.
Oh, that's very big brain of you. This is not necessary, but it actually does give us some insight into the structure of the
Doing
graph.
what?
Is what you said?
Yeah.
It's very interesting. Raises such deep philosophical questions.
Isn't that all what is?
Sure.
Some would say math is the root of all philosophy.
Mm,
It's a debatable statement. Ask Russell,
J. Wilson.
Berkshire and Russell, he'd say. Ask Wittgenstein,
Wittgenstein.
he'd say.
No.
Yes.
He'd say sure.
Is that the root of all philosophy?
Sure.
Sure. No, that actually is a great use of the word sure. Someone asks you some question and you're just like, dude, I don't want to talk to you about this. You say, yeah, sure.
Say, is it?
I don't know. What do you think?
IDK.
IDK. Okay, so this guy's going to cross the x-axis at what numbers?
0.
Zero.
Negative
Zero.
2. And 2.
Everyone okay with that?
Yeah.
Now, there's the interesting part. How
We don't
when
have
it
to-
crosses 0, it's very interesting behavior because it's almost like he's going to cross 0 2 times.
So maybe it's like.
But that's not logically possible. You can't cross the axis at one point 2 times if you're a function.
Weird movie.
Loop-a-loop.
Because then you wouldn't pass the vertical line.
True, you're right. Yeah, you could have some curve that like there's these things called like polar curves that do stuff like this that like could like cross twice. But
It's a fishy.
for this, what happens? It actually is there's a name that's called like a double root or a root of multiplicity too. The vocab's not super important, but maybe say double root. It's good that we can all be on the same page. But so this is going to cross. We said it crosses at 0, 2, and -2, right?
Yes,
So-
sir.
Make sure you label your graph. So put the numbers on there, 2, -2. Okay, so what shape is a fourth power?
Isn't? Oh.
It's
It's just a long parabola.
A plain old fourth power looks like that, but it's actually possible to add extra terms and have it get all wiggly. What's really important though is the end behavior. So you could add extra terms in here and get sort of like this behavior.
Is that what that happened?
Well, yeah, because how's he possibly going to cross the x-axis 3 times if he just looks like that? It's not possible. He must do something over here. Now here's long story short. He has this end behavior. There's no way around that. He's going to come down, pass through, bounce off the origin. Look at that, bouncy, bouncy.
How do you make sure that it's not going like? Oh wait, never mind. That wouldn't even make sense.
Okay, so there's a bunch of ways you can now think or ask yourself, okay, why does this happen? Why does it do this? Well, here's some food for thought. If I plugged in +1, can I see without putting in a ton of tedious work that this function needs to be negative when x is 1? Is that difficult to confirm?
Look at it.
Well, the graph,
Just look
I'm
at
asking if the graph is accurate. So I come back to the function, I say, if I put a 1 in there, what's 1 to the 4th power?
1.
Okay, so it'd be 1 minus 4, which is -3. So when x is 1, the y value ought to be negative. Ought to be.
Ought to be.
Wait. But what if you put negative?
Plug a -1. What's -1 to the 4th?
-1.
Wait, -1. 1.
Positive. What's
1.
negative 1 squared?
1.
So plugging in negative 1 is the same as plugging in positive 1.
C.
Thus, symmetry.
Thus.
That's a good question. Just test it. You can also look down at this part too. You can say, oh, if I plug in a number bigger than 2, let's plug in a number like 3. 3 squared times 3 plus 2 times 3 minus 2. Those are all positive numbers, right?
Yeah.
Positive, positive, positive means
So
positive.
it rises.
So we're above the x-axis. Let's hurry up for time here. Doing so great.
Show me.
Could we please do number 6? Just.
May,
just-
you are really making me earn the big bucks today, aren't you? Okay.
Because I don't want to get it wrong. I'd rather just learn the right way.
Okay. Just for you, May.
Thank you. Because okay, if it's like a number that's divisible by, that you can divide, let's say it's like that 3 and you can divide each part by 3, can you do that? To make it simpler?
Those are all divisible by 3, you can factor out 3x.
Technically, yes, but
It's
you're
not
gonna make the
gonna
problem
help
much harder that way. That's a technically possible way to do the problem. Because yeah, you'd have x squared minus 13 thirds minus 10 thirds,
Well,
and
I'm
figure out what two numbers add up to.
She's saying if it was.
I'm saying if it's all divisible by 3, can you
Then-
just divide out the 3?
Oh, of course, yeah.
Okay.
But since these are not multiples of 3, what you gotta do, the standard method would be you put a 3x
Oh,
and put an x there.
Oh,
I remember not.
I don't. Oh, that's confusing.
Uh-oh. It's okay, we're reviewing it here.
Oh.
I'm kind of kicking myself for not putting more of these on there. I thought,
Uh-oh.
it's
You
okay.
thought we were smart.
You guys are very
You
smart.
thought you told us at the beginning of the class that we had
I
intelligence.
think you guys are smart. What are you talking
7 months.
Sure.
I did, yeah.
about?
I don't know.
It's okay. We all forget things. So let's see. Can we think
We all
about?
never learn things.
You learned this. Don't lie.
I used
Don't
Slater last year.
That's intelligence.
Okay. So first of all, if you were to FOIL this out, multiply it out, what must be true about these two numbers? They must.
It must go back to that.
Well, they have to work out in a way that this is a polynomial, but when you multiply out two binomials, don't you go this times this first?
Yeah.
Makes 3x squared. Okay,
Yeah.
we're good
And
there.
the outer one.
Then you go this times this, and you go this times this, and those combine.
Yeah.
Those
And
are
then-
somehow combined into this, right?
So, that's a head
But the last
scratcher.
step is this times this gives you. So these numbers there's only a couple options.
There's
here.
only like 2, 5, -2. Wait, 2, 5. Yeah, that's literally like.
It's either a 2 and a 5 or a 1 and a 10.
And tell us when
And now there's some ones negative and ones positive. So it's either
5 and -2.
if you really want to list out every possibility, which I don't
Yeah.
know
It's
how to
5
do
and
that.
negative.
It could be 5 and -2, -5 and 2, 2 and -5, -2 and 5, or it could be tens. But it has to work with this 3. So let's do one that's wrong.
I know it.
No, that's gonna
I
make
believe
it
you.
worse.
Okay, let's say we went plus 5 minus 2. That's a problem because you go 3x times x,
Just 3x squared.
then you go 3x times -2,
Hold on.
5 times x. Oh,
Oh, and
what?
it's like.
That doesn't make it -13x. That doesn't work, right?
It's gotta be -2.
-2.
So this is where having a little bit of mental math ability definitely helps. Make it faster. How do I get to -13? Well, what if I put a -5 here to make a -15 with him? And then the +2 combines with him to make the -13.
Oh.
Now, that being said, if your mental math skills are not super great, there's plenty of great mathematicians who
Can't do
struggle
math.
with it. No, they struggle with arithmetic.
I think the great mathematicians probably can do math. They might be their special.
No, it's actually pretty common, like mathematicians who can they do really high level math, but stuff like, oh, what two numbers add up to 13 and multiply to be 10, stuff like that, that's
Yeah, just
not
yeah.
something they're,
I feel like that kind of just takes some general,
Yeah, so you gotta be tricky here. Now here I'll actually misspoke, because technically it's what two numbers multiply, it's hard to even say, but basically it has to be this times this plus this times this has to make that, which is hard to do in your head, right? But so what you do is you just kind of like put them in and you test. You go, okay, negative 15 plus 2 makes negative 13. 2 plus negative 5 makes negative 10.
Yeah.
Cool beans?
Cool.
So what are the two x values where this thing,
It'd be x equals 5.
we got 5, that's good.
And 2/3. Negative, no, just 2/3. Negative 2/3.
Yeah. Very good. Does everyone understand how we had negative 2/3? So this guy, we're asking the question, what would I have to pick for my x value to make this equal to 0?
Subtract 2 divided by 3.
So I have 2 divided by 3, you get there's your x value. Is everyone okay with that?
Yeah.
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 Yeah. So then that would be a parabola.
Happy parabola too.
Happy because I'm happy.
Like that.
I'm so bad at drawing.
Ooh, that's a scary happy.
Mine is.
Okay, so now our last little bit of time here. 2 minutes. So we're gonna have some. Took us a little bit longer to get through than I thought. That's okay. So look at number 9. So last one we'll go. Number 9. Does it look a little scary?
I need a tutor.
Maddie's like,
It's actually easier than the other ones because it's already factored for you. So you don't actually need to factor. So when you have this,
Oh, that's just like two.
okay, so this will be a little bit of a fast explanation, but where are the two x values where this thing hits 0? What are the two x values that would make this whole thing equal to 0?
0.
No.
Oh, 3 and negative 1.
3 and negative 1. Does everyone understand that? We sure?
I think so.
Okay. 0 doesn't work. So if I plug in 0 here, it would be negative 3 squared times 1 cubed. That's not 0. But if I plug in 3, I get 0 squared times 4 cubed, which is 0. If I were to multiply this out, what would be the lead term, you think?
It'd be x to the third.
X to the 5th plus a bunch of jumps. Why?
What shape is this?
I'll just here's the answer. You ready? Then go to lunch. Okay. Bouncy, bouncy. All right. Have a good lunch, everyone. See ya. Think about that.
Oh no.
Winky, winky.
Winky, winky.
Oh,
What is the answer to
Where'd that shark just go? Or did I just?
yo no sé.